Pikkoserver is an application-level gateway. It works as a server layer that load balances and scales online games. This is what it looks like. Here is an example of a 3D game seen in 2D. Players are represented as circles, and the game servers, the game nodes, have their own color, and each server's center is shown as a rectangle. The players are dynamically divided among the nodes by Pikkoserver's masked algorithm, as it constantly adjusts the distribution between the players and nodes over time for optimal balance. When a player moves, its state is transferred from one node to another. A handover has been made, as we choose to call it. While the clients can see and interact seamlessly with all the other players through Pikkoserver, a node only handles game objects moving in a small part of the game world. If a large group of players would move, the masked algorithm would adjust for this, distributing the players evenly between the available nodes within milliseconds. In this demonstration, we have slowed things down. Normally, the Pikko masked algorithm updates the world partitioning 5 times every second, and a handover takes only a millisecond to conclude, making sure changes are incremental and smooth. Adding a new node to help cope with load is simple. When Pikkoserver becomes aware of a new node, it starts assigning it players from the other nodes, where it does the most use. Removing a node is just as easy and works pretty much in the same way. This is great for maintenance, updating code, and adding assets. So what happens when players start moving to the middle? Again, the masked algorithm makes sure that each node always handles the optimal amount of players, even as they move closer together. Pikkoserver allows you to turn a simple, single-core server architecture into a seamless, scalable, and distributed system. Since Pikkoserver operates on the information stored in the headers in the network protocol, an integration in a game engine is limited to adding 4 main internal RPCs. This shows that the complexity normally associated with the building MMOs and maintaining a distributed system is greatly reduced by Pikkoserver. Pikkoserver is able to handle a massive amount of network traffic, fast. Since no two games are alike when it comes to update frequency and load, we choose to look at a game's number of network operations per second in a shared instance. By distributing the server-side responsibility for a map over 8 nodes, we were able to handle 4.5 million NWOs, adding only 10 to 18 milliseconds extra in round trip time, depending on hardware setup. Compared with a typical Battlefield game, this gives a pretty good picture of the difference in technology. Battlefield, 60,000 NWO. Man versus machine, a lot more. Pikkoserver provides a set of solutions to handle internode and client traffic, but without prioritization of the communication, the traffic will, in the extreme case, grow exponentially and beyond the capability of any system. But given this restriction, Pikkoserver is able to scale a game, as we have demonstrated, practically indefinitely by adding new nodes. Find out more on our homepage.